Question number 15. As per given, change in temperature is your 1 degree Fahrenheit. So first we will convert the change in Fahrenheit is how much change in the degree Celsius. As we know, so delta C by 100 is equal to your delta F by 180. So delta C is your 100 by 180 into delta F. Delta F given your 1, this becomes your 5 by 9 degree Celsius. It means 1 degree change in the Fahrenheit is equal to your 5 by 9 degree change in the Celsius scale. Now we have to find the change in the length of the rod. The change in length. So we can write change in length delta L is equal to your L alpha delta theta. L is the initial length, that is given 1 meter. So 1 alpha given 10 power minus 6 and delta theta your 5 by 9. So finally answer is your 5 by 9 10 power minus 6 meter. So this is the change in length. So our answer is your option number 1. Question number 16. If I is the moment of inertia of a solid body, the change in I corresponding to a small change in the temperature delta T is first option your alpha I delta T, second option 1 by 2 alpha I delta T, third option 2 alpha I delta T, and the fourth option 3 alpha I delta T. See how to do this one. So as we know, moment of inertia for any object can be written as mk square. K is the radius of gyration. So if any change in the I due to temperature, delta I is nothing. It is the change in M is never changes. On heating, M is never changes. So 2 times change in radius of gyration. And our radius of gyration just like a radius here. So this is your delta I, which is equal to 2 times delta I. Delta I means alpha into delta T. The change in the moment of inertia is your 2 alpha delta T is the moment of inertia into I. We can write 2 times delta K into I. So our correct option is your option number 3. Now question number 17. A copper rod of length L0 at 0 degrees Celsius is placed on a smooth surface. Now the rod is heated as to 100 degrees Celsius. Find the longitudinal strain developed where alpha is the coefficient of linear expansion. The option number 1 is given 100 L0 alpha by L0 plus 100 L0 alpha. Option number 2 is given 100 alpha. Option number 3 is given 0. And option number 4 is given none of these. So main important point here, this is basically a conceptual based question is there. Okay, now this rod kept on a smooth surface. When it kept on a smooth surface, the main thing is that for elongation certain force is needed from the ground. But ground is your smooth, so no force will be there. So that's why it is unable to expand. So linear expansion of the rod will be 0. So our correct option, your answer number 3 is our correct option with 0. Question number 18. Now see the question is this. A uniform rod of length L is regarding fixed between 2 ends. It has a crack at its center when the system is heated by theta degrees Celsius. The rod breaks up the displacement after center of the rod is. Alpha is the coefficient of linear expansion. Our four options are, option number 1 is L root over alpha theta by 2. Second option L by 2 root over alpha theta. Third option L by 4 root over alpha theta. Fourth option L root over alpha theta by 3. So question is this. Okay, this is rod and this rod is fixed with the two support. Here length here L. Now when it heated, so due to heat, the length will be your L1 plus alpha theta. But since it is your fixed, so it cannot expand. Because of that, it breaks from the middle like this. Crack is developed and it will bend like this. So they are asking how much is this value, your y. So this is your L by 2 and this is your L dash by 2. So from here we can write L dash by 2 whole square is equal to L by 2 square plus y square. Now y square is your L dash by 2 square minus L by 2 square. Substitute the value of L dash. L dash is your L 1 plus alpha theta by 2 square minus L by 2 square. Now we can take common. L by 2 whole square we can take common, and then what is left here? 1 plus alpha theta square minus 1. Now, so y is your L by 2 and this we can expand binomially. 1 plus alpha theta square minus 1 to the power 1 by 2. So this we can expand binomially. L by 2 1 plus 2 alpha theta, 2 alpha theta to the power 1 by 2. So this is your L root over alpha theta by 2. So this is our option. So option number 1 is the correct answer. So we can write answer number 1 is the correct option. Question number 19. Question is this. At 20 degrees Celsius, a steel ruler of 20 centimeter long is graduated to give correct reading. But when it is used at a temperature 40 degrees Celsius, what will be the actual length of the steel ruler? Alpha is given 1.2 10 power minus 5 per degree Celsius. So options are, first option your 22.0 centimeter, second option 19.6 centimeter, third option 20.0048 centimeter, and the fourth option 18.00 centimeter. It is given at 20 degrees Celsius, a steel ruler of 20 centimeter long is graduated to give correct reading. So steel scale, this is your steel scale and its length is 20 centimeter and it gives correct reading at 20 degrees Celsius. But when it is used to at temperature 40 degrees Celsius, what will be the actual length of the steel scale? So actual length, they are asking the actual length. So actual length here L is equal to L theta is equal to L 1 plus alpha delta theta. L is your 20, 1 plus alpha value 1.2 10 power minus 5. And change in temperature your 20. So this we can simplify. 1 plus this your 20, 24 into 10 power minus 5. So L theta your 20, 1.00024. So finally we can say this is your nothing 20.004 some value in centimeter. So our answer is your approximately your third option is the correct option. So hence answer number third is the correct option. Question number 20. It is given as the figure shows a glass tube linear coefficient of expansion is alpha, completely filled with a liquid of volume, expansion coefficient is gamma. On heating, length of the liquid column does not change with respect to ground. Choose the correct relation between gamma and alpha. So first option is given gamma is equal to alpha. Second option gamma is equal to 2 alpha. Third option gamma is equal to 3 alpha. And fourth option gamma is equal to alpha by 3. See, as per the diagram, this is the container and the liquid you are filled up to the brim. Now they are saying on heating length of the liquid does not changes. So whatever the expansion in the liquid, that we can say change in the area. So expansion coefficient, see on heating we can say like this. This may be the change here. So whatever change in the volume of liquid and the expansion coefficient of liquid, that will only the fill in this space and that space filled because of the change in the area of cross section. So gamma and surface coefficient that must be equal to your 2 alpha. This is the correct option. So or we can say simply in case of cubical expansion, if all three sides are there, so alpha 1 plus alpha 2 plus alpha 3, but one side is not changing, so alpha 3 is your 0 and alpha 1 is equal to alpha 2 is your alpha. So gamma is equal to 2 alpha. So our correct option is your option number 2. So hence option 2 we can make in our option. Question number 21. The coefficient of linear expansion of an homogeneous rod changes linearly from alpha 1 to alpha 2 from one end to the other end of the rod. The effective coefficient of linear expansion of the rod is first option your alpha 1 plus alpha 2, second option alpha 1 plus alpha 2 by 2, third option your root over alpha 1 alpha 2 and fourth option your alpha 1 minus alpha 2. See how to do this one. As per the question it is given, let this be your rod. So alpha is proportional to your x. X is your distance from one end of the rod, and at this end is given your alpha 1 and this your alpha 2. Linearly changes. So let total length of the rod your L. So at x distance alpha at distance x is equal to your alpha 1 plus alpha 2 minus 1 by L into x. So here in the dx. So change in the length dx is equal to, if we are looking at this distance x here, as we know L is equal to L naught 1 plus alpha theta. If alpha changes, so dl is equal to your L naught theta d alpha. Similarly, so we can write here dx. dx is nothing, change in the, this is in the dx length, we are looking here dl. So better we can write dl is equal to your L naught means dx theta, and at this point alpha is your alpha 1 plus by L into x. Now total elongation delta L is equal to, integrate x value here from 0 to L, alpha 1 plus into theta dx. Now simplify. When we are simplifying here, theta alpha 1 L plus alpha 2 minus alpha 1 by L, L square by 2. After substituting the value, check it, 2 alpha 1 positive here. So we are getting here L alpha 1 plus alpha 2 by 2 into theta. This is the actual change in the length, and as we know, change in the length, so delta L is equal to your initial length L alpha effective into theta. So alpha effective will be here, so alpha effective will be alpha 1 plus alpha 2 by 2. So hence our correct option here, option number 2. Question number 22. Question is given as, a vessel is filled with a liquid such that 20% of the vessel volume is empty. It is found that at all temperature that the volume of the empty space above the liquid surface remains the same. Then the ratio of cubical expansion of coefficient of vessel and liquid is, first option your 4 by 5, second option your 5 by 4, third option your 2 by 5, fourth option your 5 by 2. Now see how to do this one. See, it is given as, let this is total, this is your vessel, and here it is given 20% of the vessel volume your fixed or empty. This is your 20%, and in 80% liquid is there. So what they are saying, on heating at all temperature the empty space above the liquid surface remains the same. So that part will you remain same. So we can say whatever the change in the volume of the whole container, out of that 20% means that will remain your empty. So see, total volume of the container your V and volume of the initial volume V dash of the liquid, the V dash of liquid is equal to your 20%, this is 80%, so this will be your 8 by 10 and 4 by 5 into V. Now on heating, V theta is equal to your V 1 plus gamma of container into T, and V dash theta is equal to your V dash 1 plus gamma liquid into T. So see here, what is given here further, V dash at theta always remain as 4 by 5 V at theta. This is given. So check it here. V theta dash, the V dash 1 plus gamma L into T. This is your 4 by 5. V theta is your V 1 plus gamma C into T. And V dash 4 by 5. V dash cancel. So what we will get here, V dash is your 4 by 5V, and this is also 4 by 5V. This will cancel. So gamma L is equal to your, so now the volume. So it is as per the question here. As per the question here, that the volume of the empty space above the liquid surface remains the same. It means this volume 20 space means now it is still remain your same. So see here, this is not the condition here. Condition will be different here. It is given whatever the initial volume of the empty space is your V by 5. That will remain your same. Now still, what we can say here, V theta means the volume of the whole container minus volume of the liquid occupied. That is your difference. Is still your same as earlier in V by 5. Substitute the value of V theta. V theta here from this V 1 plus gamma C into T minus V theta dash. V theta dash here V dash. V dash is nothing, 4 by 5V. 1 plus gamma liquid into T. This is your V by 5. Now simplify. V and V we can substitute here. 1 plus gamma C into T minus 4 by 5 1 plus gamma L into T. This is your 1 by 5. So 5 plus 5 gamma CT minus 4 gamma L into T. This is equal to your 1. So this 5 and this 5 cancel. So we will have gamma C by gamma L is equal to your 4 by 5. So ratio of cubical expansion of the vessel, C for your container or vessel, by liquid 4 by 5. So our correct option your option number 1. Question number 23. The question is given as a 1 liter glass flask contains some mercury. It is found that at different temperature the volume of air inside the flask remains the same. What is the volume of mercury in this flask if coefficient of linear expansion of glass is 9×10⁻⁻6 per degree Celsius, while coefficient of volume expansion of mercury is 1.8 × 10⁻⁻4 degrees Celsius. Option 1 is given 50 cubic centimeter, option 2 100 cubic centimeter, option 3 150 cubic centimeter, option 4 200 cubic centimeter. First of all, question is like this. Let this here any flask. In this flask some mercury is there and this is here air. So they are saying on heating the volume of air inside the flask remain the same. This volume will remain your constant. It means whatever the increase in the volume of the whole flask, that will be equal to the change in the volume of the mercury. See, given data is your alpha for container and a flask, that is also given. That given as your 9 into 10 power minus 6. 9 into 10 power minus 6 per degree Celsius, and cubical expansion for Hg. Hg means mercury, that is given 1.8 into 10 power minus 4 degrees Celsius. 10 power minus 4 per degree Celsius. So one thing we can say, let V dash is the volume of mercury and total V, total volume of the container your V. So what is the main point here? Change in volume. V theta minus V dash theta, that is always remain your constant, and this is same as initial in V minus V dash. So V minus V dash are the initial, and that is also your remain same as temperature theta. See, V theta means here V 1 plus 3 alpha C into theta minus V theta dash. V theta dash means here volume of mercury, which is an initial your V dash 1 plus gamma of Hg into theta, which is your V minus V dash. V minus V dash, that will cancel. So 3 V alpha C theta is equal to your V dash gamma Hg into theta. Now theta and theta we can cancel. So first thing we can write here 3 alpha C. 3 alpha C or 3 into alpha C, 9 10 power minus 6 V, that is equal to your V dash. V dash is and gamma of Hg 1.8 10 power minus 4. To simplify this, 27 or 0.27 into 10 power minus 4, 1.8 10 power minus 4 V dash. So that gives us V by V dash is equal to 1.8 by 0.27, and this is nothing 2 by 30 or 20 by 3. So this is your 2 by, or we can say 20 by 3. So this is the ratio of the volume. Now it is given as 1 liter glass flask. Total volume your 1 liter. So V is your 1 liter, as V is equal to 1 liter means 1000 cubic centimeter. So V dash your 1000 into 3 by 20. So this is nothing 1500. 0 cancel. 215 150 cubic centimeter. This is the volume of mercury. So correct option your, or option number 3 is our correct option. Now question number 24. The diameter of a metal ring is D and the coefficient of linear expansion is your alpha. If the temperature of the ring is increased by 1 degree Celsius, the circumference and the area of the ring will increases by. The first option is pi d alpha and 2 pi d alpha. Second option 2 pi d alpha and pi d square alpha. Third option pi d alpha and pi d alpha by 2. And fourth option pi d alpha and pi d square alpha by 2. See, as per the given question here, this is the metal ring and its diameter is your D given, or radius is given here D by 2. on heating. The circumference, first is your circumference. If I am talking about, L is equal to 2 pi r or pi into d. On heating, L dash is your 2 pi r dash, or 2 pi r dash means r 1 plus alpha theta. L dash, so pi r is your 2 r is your d, pi d 1 plus alpha theta. So change, the change in circumference, that is your L dash minus L or pi d minus d. So this is your pi d alpha theta. This is the change in the and theta is your 1. So as theta is your 1 degree Celsius, so delta L is your pi d alpha. Now, if we are talking about the area, in case of area, for area of the ring, is your pi d square by 4. So now this is the initial area A. Now A theta your pi by 4 and nu theta in d theta square, pi by 4. D theta value we can get from here. D theta is nothing, d 1 plus alpha theta whole square. In that manner we can write. So pi by 4 d square is the initial area. So A theta is equal to A 1 plus 2 alpha theta, because binomial exponent alpha is very, very small. So this is change. The change in the area can be written as A 2 alpha theta, and alpha is theta is your 1, and A is your pi d square by 4 to alpha. So finally this is your pi d square alpha by 2. Pi d square alpha by 2. So change in the area. Change in area, pi d square alpha by 2, this, and change in perimeter, pi d alpha. So change in perimeter, pi d alpha, and change in area, pi d square alpha by 2. So our correct option is your option number 4. Question number 25. If the coefficient of real expansion gamma r is your 1% more than the coefficient of apparent expansion, linear expansion coefficient of the material is, first option gamma r by 303, gamma 2 is your, second option 100 gamma r by 101, third option 101 gamma r by 300, and the fourth option 100 gamma r by 100. So gamma r is your coefficient of real expansion. Gamma r, it is your coefficient of real expansion. This is given. Coefficient of real expansion. And it is your 1% more than the coefficient of apparent expansion. So real expansion and apparent, this your gamma is your coefficient of apparent expansion. So it is given as real expansion is your coefficient of real expansion 1% more than the coefficient of apparent expansion. So this is your, it means now it become your 101 by 100 times your coefficient of apparent expansion. So now they are asking the linear expansion coefficient of the material. The first thing, gamma are the coefficient of real expansion. So apparent expansion is equal to your real expansion of material, real expansion of the liquid minus apparent minus real expansion of the material. So they are asking the value of alpha for material. See, gamma m is equal to your gamma r minus gamma of apparent, which is equal to gamma r is here this, or gamma r 1 minus apparent expansion 100 by 100 This is your gamma r by 101, and gamma material means 3 times alpha material, which is your gamma r by 101. So alpha material is your gamma r by 303. So this is the coefficient of linear expansion of material. So option number 1 is the correct option. Question number 26. A closed bottle containing water at 30 degrees Celsius is carried to the moon in a spaceship. If it is placed on the surface of moon, what will happen to the water as soon as the lid is opened? First option, the water will freeze. Second option, the water boil. Third option, it will decompose into hydrogen and oxygen. And the fourth option, nothing will happen to it. As we know, when we are going to the moon through the spaceship, the atmospheric pressure at the moon is very less. So as the pressure here decreases, boiling point of this here increases. So as soon as the water will go into the moon, so since pressure is very less, it immediately start boiling. So correct option here, option number 2 is the correct option. It start boiling because the boiling point will increase, or we can say at the 30 degree temperature itself it start boiling. Question number 27. Question is that a sphere is heated from 0 to 4 degrees Celsius and its density decreases by 0 to 4%. The coefficient of linear expansion of the material of the sphere is: first option 10 power minus 4 per degree Celsius, second option 1.6 10 power minus 5 per degree Celsius, third 3.3 into 10 power minus 5 per degree Celsius, and fourth 6.7 into 10 power minus 5 per degree Celsius. In this question they are saying, let this is the sphere and it has been heated from 0 to 40 degrees Celsius. It means initial temperature was 0 degrees Celsius and heated to 40 degrees Celsius. So its density decreases by 0.4%. Here density D1, here density D2. So it is given D2 minus D1 by D1 into 100. This is 0.4. So they are asking the coefficient of linear expansion of the sphere. So we can write from here D2 by D1. This is actually negative. So this is your negative. Why? Because the density is decreasing, so this term should be your minus. So D2 minus D1 minus 1, that is equal to your minus 4 into 10 power minus, this is by 100, so minus 3. Now D2 by D1 is equal to 1 plus 4 into 10 power minus 3. So they are asking the coefficient of linear expansion. So d2. d2 is nothing, it is your d1 by 1 plus 3 alpha into theta. 1 by d1 10 power minus 3. So we can simplify from here. So this is your, then now check it. This value can be written as 1.004. See, now we can refer here 1 plus 3 alpha theta is equal to your 1 by 1.004. 1 plus 3 alpha value we have to find, theta is your 40. So 120 alpha is equal to your 1 by 1.004 minus 1, since alpha this is your negative term. So alpha value we can get mod of 0.004 by 1.004 into 120, and after solving we will get this is your 3.3. So alpha is approximately 3.3 into 10 to the power minus 5 per degree Celsius. So the correct option, your option number 3 is the correct option. The question is given as the apparent expansion in liquid depends upon A statement given nature of liquid, B statement given nature of vessel, C statement given scale of temperature. So in the first option they are saying only A and B are correct. Second option they are saying only B and C are correct. Third option they are saying only C and A are correct. And fourth option they are saying all are correct option. The first thing, apparent expansion. Apparent expansion is here. Apparent expansion of liquid is equal to real expansion. Real expansion minus expansion in material. Expansion in container material. In container. So the apparent expansion depends on the nature of liquid as well as nature of vessel or container. So nature of liquid as well as nature of vessel, so A and B are our correct option. So hence the option number 1 is the correct option, because it depends on the nature of liquid as well as nature of vessel.